Hello. Now our next work was to deploy a distributed application on vCloud. So for deployment, we choose a data mining for market basket analysis in a distributed system. Data mining is the process of extracting useful or hidden predictive information from a large data sets. Uh, for data mining, we use association rule mining, and it is two pass process. The first is calculating the frequent item sets, and the second one is generating the association rules by using this the frequent item set that we have calculated in earlier stage. For association rule mining, we made some changes in a priori algorithm to minimize the time requirement and then deploy the application on vCloud. Unlike the count distribution algorithm for calculation of frequent n item sets, we used frequent n minus item sets only. So it minimizes the size of the calculation and also the time requirement. Next section, we will describe the functional view of our algorithm. Yes, this is the functional view of our algorithm. uh, in this algorithm, any number of nodes can participate in the calculation. One of the node act as a master node, and any number of node can act as a compute node. Each node in the algorithm has its own local database that it can use to create some data structure, some useful information. In this application, we have created a number of virtual machines, and one of the virtual machine act as a master node and another one as a compute node. Since the memory requirement is large, because the big amount of data is required in memory, so we have used Hazelcast in memory data grid. Because Hazelcast has its own recovery mechanism from failure, it is best suited for this application. Here the algorithm work as follows. Here is the Hazelcast memory pool, that is the combined memory from all the nodes that are participating in the calculation. First, the each and every node, including the master node, read its local data set and calculate the frequent one item set, and writing back into the data structure that is available on the Hazelcast memory pool. Once every node calculated the one frequent item set and writing is over from every compute node, they send a ping message to master node, and then master node start the writing the frequent one item set on a persistent storage. Once it completes the writing on the persistent storage, it again send a message to all compute node to start the next phase. As soon as the compute node got a message from master node, they start the two frequent item set calculation using the one frequent item set that they have stored in local database, using local database and global frequent item set that they have calculated earlier. Again the same procedure repeats. Once the compute node finish that their work, they again send a message to master node, and again master node write the two frequent item set on the storage, persistent storage, and clear the data structure, and again they send a message to the compute node. The process continues till the final frequent item set is calculated, and at the end we got the frequent item set, the set of frequent items that will be useful for calculation of association rules. The computation done in this model is distributed, so we just need to calculate the frequent item set distributively, and the association rule calculation can be done either centralized or it can be distributed also. So let's take a view of the application that we have deployed. So here is the link, uh, here is the login window. We log in as a user1, and password is secret. Yes, we have logged in. Currently we are running this application on the two virtual machines. It's virtual machine 3 and virtual machine 4. These are the running virtual machines. Okay, this virtual machine 3 and this is virtual machine 4. In virtual machine 3, we have a master. The virtual machine 3 work as a master node, act as a master node, is the application, and the local database is stored on the desktop. It is the test1 dataset, and the final item set that we calculated will be stored in this directory. Its name is item set. This is the older one, so let me delete first this. Okay, now it's fine. Okay, this is our master node. These are our compute nodes. The compute nodes have different work. So these are the compute nodes. Let's start the application. And the compute node also have their own dataset. These are the test dataset 2 and test dataset 3. Let's run this application. Here it started. First it started the Hazelcast, and currently only one member in the Hazelcast. Only one node has shared its memory in the Hazelcast, and now it is waiting. It is running its calculation, and it is also waiting for the uh, commit message from the compute nodes. Now this is the compute node 1, so let's run the compute one first. This, okay, now run it. As soon as it got run, it sends a socket request to master node, and the master node accept the socket request. Now there are now the two members in the pool of memory, and it starts working. Yes, now run this third node. It also works as an instance of Hazelcast, and it also got engaged with the shared memory pool. Yes, it got. The calculation takes some amount of time. It is going, it's running. Simultaneously, the iteration count values, it will be shown here. Once they committed, the iteration count will be incremented. Yes, we can see here incremented value is 4. Now the calculation for 5 is going on. Yes, now the iteration count value is 5. Now the calculation for 6 is going on, and so on. Okay, now the result has calculated, and they have committed the result in the final destination folder, so we can verify the result from here. Yes, item set has the result documents. This is the calculated 1 frequent item set, 7 frequent item sets, their corresponding list of the transactions, and also the 10 frequent item sets. Okay, this brings us the end of this video. Thank you.